right, guys, we are finishing up the second part of 3.6, and where we stopped in our first part was a reminder that x to the nth power and x to the negative n are reciprocal functions, and we proved that by showing that x to the n times x to the negative n equals x to the 0, and anything to the 0 power is 1. So let's take a look at how to graph some functions. We have our given function over here on the right-hand side, and if you want to read these instructions, they are outlined for you on page 145. Now, this can be kind of difficult to explain over a slide with PowerPoint, so I will do my best, but we will definitely go over this in class as well. So we see our function over here on the right-hand side, and what you have seen up here is all the places where y equals 1 or negative 1. And so we've got these, not asymptotes, but little guidelines here that we've drawn to notice the places where the function is 1 and then the places where it's negative 1. Since the reciprocal of both 1 and negative 1 are 1 and negative 1, these points are also going to be on the reciprocal function. So these places right here, it's not right on the dot, but these places where x or y equals, 1 and negative 1, we've got 1 right there, and there, and there, and there. When we graph the reciprocals of those, the reciprocal of negative 1 is negative 1, and the reciprocal of 1 is 1. So we've got these dotted lines here to help us kind of visualize where y equals 1 and negative 1. And so when we create our reciprocal function, which let me change my marker color here, we're going to see the graph of the reciprocal function at the end, but I don't want you to see it until the very end. So when we create a reciprocal function, I'm going to do it right on top here. We know this point, and this point, and this point, and this point will all be on the graph that we create of our reciprocal function. So we're going to go ahead and graph our reciprocal right on top of our regular function. So just a reminder, we're using these horizontal guidelines. They're not asymptotes. They're not going to be part of the graph, but using these guidelines to help us find that y equals plus or minus 1, because we know the reciprocals will also be on the graph. So we've got 5 points already on our graph. The next thing that we're going to do is look for our vertical asymptotes, where our zeros are. Now, in our original function, our zeros are right here at x equals 2 and x equals 6. And where we have zeros in our function, if we do the reciprocal of that, we now have 1 over 0, which is undefined. So where we have zeros on our original function, on our inverse function, that's where our vertical asymptotes are going to be. So I'm going to go ahead and draw a vertical asymptote here. And where's my other one? Right here at x equals 2 and x equals 6. On my original function, those were just 0. But because we know inverses is 1 over those x's, we now have 1 over 0. Undefined, so there's a vertical asymptote there. So we've got those drawn. So that's our second step. So first step is to use the horizontal lines to find the y equals plus or minus 1, because we know those points will be on our reciprocal function. Our second step is to find the vertical asymptotes. So anywhere in our function where x originally equaled 0, where y originally equaled 0, is now where we have those vertical asymptotes. Right now, some steps will recommend that you create then a chart here for your original x values to find what your inverses were. So we're actually going to make a little chart, even though there's not one in your book. But we're also going to use some logic to figure out what these would look like as well. So let's pick an original f of x here. So when f of x equals, when y equals here, when y equals 2, what would our inverse be? 1 over f of x would now equal 1 over 2. So our original y-intercept was 2, but on our reciprocal function, it's going to be y equals 1/2. So I'm going to make a mark right there. Okay, let's look at our peaks and valleys here. And we can see here that y was equal to negative 1, 2, 3. Well, the inverse of that, negative 3, is negative 1/3. So I'm going to put a mark right about, here, negative 1/3. And I could do that all along this graph. Just pick some y points and then plot their reciprocals to kind of see what these functions are going to look like, but we can also use some logic here. All right, looking at the left tail of my original function, it looks like my left tail is getting closer and closer to 0. So let's pick some arbitrary fractions. Maybe this was 1/2, and maybe this is 1/3, and this is, maybe 1/6 or 1/9 or 1/12 or 1/100. The reciprocals of 1/2 would be, if that were 1/2, then it would be 2. And if this were 1/3, that would be 3. And if this were 1/6, it would get to 6. So as my tail is getting closer and closer to 0, what the reciprocal of that is that now my tail is getting closer and closer to infinity. So I'm just going to sketch this. This is not exact. All right, what about over here? You can see over here, on my original function, my right tail is getting closer and closer to infinity. My numbers are getting bigger and bigger and bigger. The reciprocals of that, if you remember when we did reciprocals of 10, 20, and 100, the reciprocals of 10, 20, and 100 were 1/10, 1/20th, 100th. So as our integers are getting bigger here, what the reciprocal of that is going to look like is that our reciprocals are going to get closer and closer to 0 without ever crossing 0. So I'm going to sketch that tail right here. So we can just kind of pick some points and figure out this is what it's going to maybe look like. We know that here it looked like this tail before we get to the asymptote was getting closer and closer to 0. So the reciprocal of that will be closer and closer to infinity without crossing that asymptote. Right here, it's going to look something like this. Ooh, without crossing that asymptote. And here, without crossing that asymptote there. And let's connect these points here. So we can sketch this graph, both logically thinking about what we know about inverses, but also we could pick some points and create a chart if we wanted to have a more exact sketch. So first, we put those horizontal lines on there to find our values of 1 and -1 because we knew the reciprocals would be the same. So that actually gave us 5 definite points on our graph. Then we looked at our original zeros of our function because we know on the reciprocals those would be undefined, so we added some vertical asymptotes. And then we used what we know about reciprocals to kind of logically sketch this graph, but we also picked some specific points like y-intercept or those peaks and valleys to help us come up with some specific points on our reciprocal function. Now, we can also notice that there will be horizontal asymptotes when f of x equals 0. Okay, right here, we can see that our 3 little parts of our reciprocal function are not crossing that x-axis. So there, we can deduce that there is a horizontal asymptote there. Right, we would then connect to sketch, and if you look on page 145 of your book, you'll see there, or actually page 146 is the finished graph of your book, you'll see that completed graph of that reciprocal function, and it does look very similar to the purple function that we've created up here at the top. All right, let's graph g of x equals 1 over x squared minus 4th. Now, the first thing that we would do would go ahead and graph our original function of x squared minus 4. And that will help us see what the original function should look like. It will help us see where our 1s and -1s are, if any. It will also help us to identify where our zeros are so we know where the vertical asymptotes will be when we graph our reciprocal function. So make sure that we're following our steps here or we are going to get lost. So first, let's graph x squared minus 4. Okay, if we put those lines here at 1 and -1, we're going to see that y equals -1 here, and here, and here, and here, 1 and -1. The reciprocals of 1 and -1 are also going to be 1 and -1, so those 4 points will be on our graph. So I'm going to go ahead and graph the reciprocal right on top of the original function. So after we found out zeros, do you remember the second step? Is to find our zeros so that we know where our vertical asymptotes will be. Okay, our zeros are right here and here. So that's going to be our vertical asymptotes. All right, we can determine the range and domain of g of x, which is kind of what we've done. The domain is all real numbers except where those vertical asymptotes exist. So our domain and range is going to be all real numbers except x cannot be equal to plus or minus 2. That's what we just sketched. And our range then be y is greater than 0 or y is less than or equal to negative 1/4. If we were to plot these points, our original low point here is negative 4, and the reciprocal of that is negative 1/4, so right about here, which means our graph is now going to go downwards, and our original have a positive y-intercept here, but we could use reciprocals. Here y is equal to 2, so here as the reciprocal it's going to be y equals 1/2, maybe right here and maybe right here, just to give us some points to kind of sketch there. We can see just looking at that y is, we're not going to cross that x-axis. So it is going to be a horizontal asymptote. Right, we've already determined our vertical asymptotes, already drawn there, and then we've added this horizontal asymptote of 0 as well. We can plug in critical points from each region. I kind of showed that here, but we can also use logic. So if we look at the tail of this function right here, our integers are getting greater and greater and greater. The reciprocal of that then will be that we are getting closer and closer to 0. So it will look something like that. All right. And again, over here on the other side, getting greater and greater and greater as we go right. So on a reciprocal, it will get closer and closer to 0 as we go to the right. And then looking at this function, we've already plugged in that negative 4. The reciprocal of that gave us negative 1/4. We could pick a few more points in there if we wanted to, like g of 0 or g of 3 or g of negative 3. That's going to give us some points to sketch. And then we will connect our dots and create that sketch, being mindful of our vertical asymptotes there. We don't want those vertical asymptotes to be crossed. Okay, now, that shifted a little bit, so my graph is now a little bit misaligned. Here's the original drawing where I have my purple ink, and here is the final drawing. Let's erase my ink here so you can see that final reciprocal function being graphed. So we're following those steps that we already determined on the previous slide. Find your 1s, find your 0s to determine your vertical asymptote, plug in any critical points, or use logic and what you know about reciprocals then to sketch that function. All right, let's go ahead and graph cosecant of x, remembering that cosecant is 1 over sine x. First, let's graph just sine x. And there is our graph of sine x. Notice that our x-axis is labeled now with radians, 1/2 pi, pi, 3/2 pi, 2 pi. Then determine our domain and range. Remember, our domain is all real numbers except for where sine of x would equal 0. And we know that, skip ahead here, sine of x is going to equal 0 at all values of pi times whatever this integer is. So 1 pi, 2 pi, 3 pi, 4 pi. Those are our different places where we have our zeros here. All right, so we know that those will now be vertical asymptotes. Our range, y is going to be greater than or equal to 1 or less than or equal to negative 1. We've determined those asymptotes, and we can draw those vertical lines there, vertical asymptotes. We can plug in critical points from each region then. So let's find sine of pi over 2 equals 1. Sine of 3 pi over 2 equals negative 1, and then we are going to go ahead and sketch those. Using what we know about inverse functions, reciprocal functions, we can then create the reciprocals inside each of those regions, inside each of those vertical asymptotes. And there is our final function there, cosecant x. Right, this function has no zeros. The period is 2 pi. It is not continuous. Right? Today we identified vertical asymptotes, domains, and ranges of reciprocal functions, and we graphed reciprocal functions. We will obviously work on this a little bit more in class, as this is kind of difficult to grasp just from a presentation. So we'll do some practice together. If you have any questions, be sure to save those for next class.